Welcome to 2.4 Congruence Postulates. We're going to talk about 3 postulates and 1 theorem in this lesson today. But first, let me remind you about what we talked about for 2.3. Remember, we were given these 2 triangles, and I said these were congruent because all 3 angle measures and all 3 side measurements were congruent. Now, you won't always be given triangles where you know every single measurement. That means you won't know all the angle measures, you won't know all the side measures. So how do you determine congruency without knowing all that information? Well, there are actually 3 postulates to help you determine congruency with little information. So let's get into the first postulate. Side, 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 abbreviated as SSS. This states that if the sides of one triangle are congruent to sides of another triangle, then the triangles are congruent. Okay, so all 3 sides, they're congruent to all 3 sides of another triangle, so these 2 must be congruent. Now what about the second postulate, side, angle, side, abbreviated as SAS? It states that if 2 sides and an included angle, you'll see I highlighted it and I'll get into that shortly. If 2 sides and an included angle of one triangle are congruent to 2 sides and an angle of another triangle, then the 2 triangles are congruent. Okay? So you see 2 sides and an included angle, 2 sides and an included angle, it is guaranteed to be congruent. But why did I highlight included? Well, this postulate states that it has to be included. So when you think of included, think of it being included between 2 things. So in this case, we have one side and one side, but what comes with it? An angle, right? Here's one side, here's another side, and an angle is included in it. And I like to remember this by thinking SAS, where the angle is sandwiched in between the 2 sides, and you can see that in the abbreviation. So this postulate, it has to be an included angle. For example, what if we had, instead of having these angles, what if we had this angle? Well, this postulate would not support congruency for these 2 triangles because this angle is not included. Here's one side and here's the other side. This side, we don't know if these sides are congruent to each other. Therefore, this angle is not considered included. Okay? Because based on what we're given, we do know that these 2 sides are congruent. So an angle would have to be included for the second postulate. Let's get into the third one. This is very similar to the second one. It's called the angle-side angle, abbreviated as ASA. If 2 angles and an included side of one triangle are congruent to 2 angles and a side of another triangle, then they are congruent. So why is it included? Well, here's one angle, here's another angle, and in between these 2 angles are a side. So same thing like the second one, the side has to be included or it has to be in between. And you see that in the abbreviation where the S is in between the 2 A's, so it's in between 2 angles. Okay, so let's get into example problems to check our understanding. This asks, are these 2 congruent? If so, which postulate proves congruency? What are we already given? We're given that segment AB is congruent to segment EF. So instead of seeing this in writing, why don't we represent that in the picture so we can visualize what's going on? So I'm going to use hash marks to indicate congruency. Next, segment BC is congruent to segment ED. Again, let's use hash marks. Lastly, segment B is congruent to segment E. Okay, so what does this look like? This looks like side, angle, side. Okay, side, angle, side. Notice how I'm not writing side, side, angle, because if I wrote side, side, angle, you would think, because we have 2 sides, and one angle. But if I write it like this indicates that the angle is not in between the sides. So you would not write it like this, because in this case, the angles are in between the sides. And SAS is actually our second postulate. Therefore, these are congruent, and the postulate that proves congruency is SAS. Next, are these 2 congruent? If so, which postulate proves congruency? Okay, so we see these are both 15. Let's use hash marks. These are both 12, and these are both 40. So what does this look like? This looks like side, side, angle, where we have two sides and an angle that is not included. That's why the angle is written here. It's not in between the two s's because it's not included. Is this actually one of our postulates? No, this is not one of our postulates, and since it doesn't follow side, 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 or angle, side, angle, it is not congruent. So these are not congruent. So now let's get into a theorem, and we're going to look at the proof. This states, this is the angle, side, angle theorem, and this is another way or another shortcut to determine congruency, in addition to the three we just learned about. So this states, if two angles and a non-included side, should erase this. Okay, pretend that wasn't there. Okay. If two angles and a non-included side of one triangle are congruent to two angles and a side of another triangle, then the triangles are congruent. What does that mean? Well, first, they're saying that if we have two angles and a side that's not included, right? If it was included, it'd be right here, but it's not. So this side is considered non-included. Then these are congruent. But how do we know that, right? How does this theorem guarantee congruency? Let's think back to the third angle sum theorem we learned about in 2.2, right? I put this little cloud here to help us remember. Third angle theorem. If two angles of a triangle are congruent to two angles of another triangle, then the third angle is also congruent, right? It has to be congruent. How does this apply to our angle, side, angle? Well, these two are congruent to these two, so the third one also has to be congruent. Now, what does this actually look like? This looks like angle, side, angle, where the side is actually included, right? So since it looks like that, it's actually like that, then this also works. Except we don't have to think about this third angle, right? We could just be given this situation. So therefore, the angle, side, angle theorem is sort of a fourth shortcut that we learned, okay? So now let's remind ourselves the congruence postulates we just learned about. We learned about side, 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 SAS, ASA. Now we talked about how the side wouldn't have to be included, right? Because if it's included, it's in the middle. But we also learned about the theorem where the side doesn't have to be included, and this would work. Now, is there such thing as having AAA or SSA, where the angle is not included, right? Because for 3, we discovered that the side doesn't have to be included and it would still work because of the third angle sum theorem. So this was sort of like skipping a step because we already know this third angle would be congruent. And that's why the side would seem included. So would angle, angle, angle work? Well, let's take a look. In this case, it does work. All 3 angles are congruent. So these triangles are congruent. But what if we had this case? All 3 angles are still congruent, but the side measures are actually not congruent, right? This is actually double this size. So these are not congruent. Therefore, AAA doesn't always guarantee congruency, right? In this case, it is congruent. In this case, it's not. So it's not always going to guarantee congruency. Whereas these 4 cases, these always guaranteed congruency. Now we already know that AAA doesn't work. Now what about SSA? Well, in this case, SSA, right, where the angle isn't included, these 2 are congruent. But what if we had something like this, where the third side is actually shorter, right? But we still have 2 sides and an angle that are congruent. But since this doesn't work, this doesn't always guarantee congruency, so this doesn't work. Because it always has to guarantee congruency. So the only four that work are these four we learned about. And remember, these are considered shortcuts so that you don't always have to know all the information or all the measures of the angles and the sides in order to determine congruency.